Okay, everyone, thank you for joining us today on the NREF Young Neurosurgeons webinar series. This is episode 15, I believe. The topic today and the title of today's lecture is The Pathways to Become a Neurosurgeon Clinician Scientist. We have two outstanding guests and an amazing panel that we're glad to be able to share with you. Before we get started, I kind of want to go over, for those of you who may be new, what the goal of this series is to provide students, residents, and young neurosurgeons with timely information, education, and inspiration towards a career in neurosurgery. The Young Neurosurgeons Committee is a subcommittee of the AANS. We try to develop the future leaders in neurosurgery and provide a channel for young neurosurgeons to impact the direction of the specialty. This is being one of those ways that we try to function to provide value. What is the AANS, you may ask? It's the American Association of Neurological Surgeons. It's a scientific and educational association. It's an organization that guides the field of neurosurgery, and its roles include many things, some of them being education, advocacy, and promoting the highest quality of patient care. So what is NREF, the co-sponsor of this webinar, you may ask? It's a Neurosurgery Research and Education Foundation. It's a not-for-profit 501c3 organization created by the AANS. It supports basic science, clinical research, as well as lifelong education to foster and improve outcomes for patients with neurosurgical diseases. They sponsor many things related to young neurosurgeons, including research grants, which are really crucial along this pathway to becoming a clinician scientist, as well as clinical courses that educate young neurosurgeons. And we are very, very happy that they have supported this webinar. Before we move forward, we just want to give everyone an update that in 2 weeks, on a Wednesday instead of Thursday this time, we'll have the next episode focused on how to go about finding a job once you get close to graduating. We'll have Dr. Golfinos and Dr. Painter talk about kind of the academic side as well as the non-academic side of neurosurgeon jobs, and we have a great panel for that one ready as well. With that, we will introduce today's panelists and then our speakers. Nicole Bentley is an assistant professor of neurosurgery at University of Alabama, Birmingham. She specializes in functional neurosurgery. Neil Majmunjar, chief resident neurological surgery at Rutgers, RBHS, who's going to go into vascular and be doing his vascular and endovascular fellowships in the coming years. And I'm not sure if she's gotten out of the OR to join us yet, but Jasmine Toom is a senior resident at Department of Neurosurgery at UCLA, where one of our guests is from, Dr. Liau. Our first featured guest, or at least one of our two co-featured guests, Dr. Frederick Barker. He's a professor of neurosurgery at Harvard, MGH neurosurgery. You can see his education there. I think this is always interesting for the students and junior residents to see kind of these very senior accomplished people's path. He got his MD at Harvard Medical School. His residency was at Mass General. I think that should be fellowship at University of Pittsburgh Medical Center, as well as another fellowship at UCSF. Let's see, next slide. He's currently a professor of neurosurgery at Harvard. As we said, he's a vice chair for academic development, the chair and co-chair for numerous IRB approved phase 1 through phase 3 clinical trials. His research is, among many other things, is in clinical trial design. He's a visiting neurosurgeon at Massachusetts General Hospital, director of the Neurosurgery Cranial-Based Center, as well as being a neurosurgeon oncologist and pediatric neurosurgeon at Mass General. Dr. Barker, very, very big thanks for being here today. Dr. Linda Liau, our other guest, who will be presenting first, is an MD, PhD, and MBA. She's the professor and chair at UCLA Neurosurgery. You can see her education here. She had her medical school diploma and degree at Stanford University. She then transitioned to getting a PhD at UCLA School of Medicine, and from there continued at UCLA through her internship, residency, as well as her fellowship in neuro-oncology. Dr. Liau, it's a great pleasure to have you with us today. She is currently the professor and chair, as we discussed. She's the director of the UCLA Brain Tumor Program, former editor-in-chief of the Journal of Neuro-Oncology. She has a number of other platitudes, including being the second female neurosurgery department chair in the United States. I believe she's the first female director of the AANS. She has a multiple NIH-funded neuro-oncology lab and has gone on to take her basic science research to translate them into clinical trials in humans. I did want to highlight that she has a really nice piece written by one of our panelists, Jasmine Toom, in the Journal of Neurosurgery Focus about her life and career, and it's really a wonderful read. And I encourage anyone who's interested to check that out. One of the things that I learned is that she had 4 NIH funding grants by the time she was 34 years of age, which is somewhat mind-boggling. Dr. Liau, thank you again for joining us. I wanted to say before we start with the slides that we want to thank our co-director, Anna Rodriguez, for all of her behind-the-scenes work, as well as Rebecca Struer with NREF, who helps put all these things together. By way of keeping everything moving, we're going to have a question and answer function during the talk. So if anyone that's watching has questions, put it in the question answer box in the Zoom functionality. And towards the end, we'll answer all the questions if we can't type an answer to them if they're straightforward. With that, I'm going to ask Becky. It looks like maybe Jasmine is struggling to get the Zoom link. If we can send that to her, that would be great. All right, Dr. Liau, I think we'll have you start off first. Tell us about the pathways from your view of how to become a clinician scientist if you're one of these young people gunning to make a difference in the world through science and neurosurgery.
Okay, great. Well, thank you so much for inviting me, and it's a pleasure to be here. I used to think I was a young neurosurgeon, but Fred, I think you and I are no longer young. So let me share my slides. So, I guess the theme of the webinar today is as Dr. Johnson said, pathways to become a neurosurgeon clinician scientist. So I'll just go over some of the kind of broad topics, and certainly we'll have time for discussion and questions and answers later on. But so what is a neurosurgeon clinician scientist? So I'm going to, kind of just go through the what, why, and how of this process. So as far as the what, and actually I looked this up in the dictionary, a clinician scientist is a physician with a direct clinical practice who invests significant time and professional effort in scientific research. So it's not just a physician scientist, or it's not just having an MD and a PhD, because there are people with degrees that actually don't have a clinical practice. So this is really what I'm going to talk about is, how to blend, a career where you have a clinical practice, but also invest a significant amount of your time doing research. And then the why. The why is actually probably the most important question. And I think for everybody, you need to ask, if you want to go down this route, the why. And the why is because clinician scientists do play a critical role in translational medicine. And clinical research. And I think physician or clinician scientists are really those people that connect the discoveries in biomedical research and neuroscience to actual healthcare applications to really kind of bring that to patients. And there is a role for those individuals. And I do believe that within neurosurgery, we have a very defined role in that. And if anything, a calling and an obligation to do that, because we're one of the few, or probably the only profession that gets to actually touch the human brain. So there is that role for the clinician scientist, but I don't think every neurosurgeon should be a clinician scientist. I mean, that's, there are 110 neurosurgery residency programs out there, and many don't necessarily train clinician scientists, but several of our, academic medical centers do. So this is really a career path that I think for those who want to do this, you really need to answer the why and have the passion to do this. And then the how, and we'll go through some details about the how in the next few minutes. So what are the challenges of academic neurosurgery? So most clinician scientists live in academic departments, university settings or academic settings, and because of that, there are many kind of diverse demands. So it's not just enough to necessarily, do clinical work. I mean, that's certainly something we need to do as part of our job, but we also strive for research excellence. And then we also teach and mentor residents and fellows. And then there's also the need for administrative service. And then with all of that, most of us also have families that we need to foster and take care of. So it's really figuring out how to balance all of these different things. And quite frankly, I can't answer that question for you because I'm trying to figure that out myself. It's balancing all of these things is a challenge, and I think it's different for each individual. And then even for a given individual, I mean, I know for myself, it's different depending on, what point of my career I'm at, and also even, depending on what day of the week it is. So in terms of, pathways to becoming a neurosurgeon scientist. So some of you may be medical students or residents and or even junior faculty. And in kind of thinking through, well, if this is what I want to be, if you figured out, well, this is my why, this is the, what I'm passionate about doing, then there are different pathways by which you could get there. Many people start, who know they want to do, research and medicine. They do go into MD, PhD programs, but that's not, it's not an absolute requirement. I mean, I think, I often get the question, is it necessary to do a PhD to be a clinician scientist? I'd say the answer is no, but you do need to make that investment of time and effort to build your kind of research portfolio and your research, abilities. So it's like, you can't be a neurosurgeon unless you train to be a neurosurgeon. You have to learn how to do certain skills, certain techniques and skills. It's the same thing with research, but whether or not you need the actual degree behind your name, I don't think that's absolutely necessary. I went to graduate school and got a PhD, and that's simply because I like kind of structure in things, and I like to have a structured curriculum in learning things. But if you're self-motivated and you're able to get the same training and mentorship without the PhD, I think that's perfectly fine. So there are different mentored research opportunities during residency. And I think the two most important things to do during residency, if you are thinking of this path, is number one, identify mentors. It's very important to identify people that will be your advocates, mentors, sponsors, coaches, basically people that will support you in this career path. And people that you could look up to as role models as to how you want to structure your career. And then the second thing is seek funding. It's never too early to look for funding, and it's really important, I think, to apply for grants and try to get funding during residency. Not so much because you need the funding; it's actually nice to have it, but it really teaches you that skill set of how to apply for grants, how to how to modify your proposals when you don't get your grants funded, because this is really kind of what you need to do throughout your career to be a viable clinician scientist. You really need to be funded. Within residency, there are different options for funding. There are institutional grants. So there's some places that have these R25 training grants, specifically for neurosurgeons or neurosurgery residents. And we're one of the institutions that have one of those. There are F32 individual training grants, and these are typically for people who already have a PhD, for instance, and they want to get a postdoctoral research experience. You could apply for an F32 NRSA grant. There are institutional T32 grants. These are grants to the institution. So, for instance, here at UCLA, we have about a dozen T32 grants in various topics, everything from tumor immunology to neurotherapeutics. So depending on what your area of research is. There are, for large universities, there are several of these T32 institutional training grants that do take residents within them. And then at the NREF, as part of the AANS, does sponsor resident research. And then there are various foundation grants like the American Brain Tumor Association and different types of foundations and associations that sponsor research grants for residents. So as far as resident research opportunities, I'll just go through some of these kind of funding mechanisms one by one, so they don't all sound just like alphabet soup. So the R25 training programs, those are institutional grants. So they're NIH grants that are given to neurosurgery departments and or neurology departments around the country with the mission of training basically clinician scientists of the future. The endpoint or I guess the metric for success for these R25 training programs is how many of these residents who are on these training grants go on to get K awards and then and independent funding later. And I've listed 10 of the institutions or neurosurgery departments around the country that do have these training grants that are led by neurosurgeon PIs. There are others that are led by neurology PIs, and those, I think some of those do take neurosurgeons within them. But these are some institutions that have a specific, neurosurgery R25 training programs. And then the PIs within those institutions are themselves clinician scientists. So I think these places do offer that environment for people who are looking to be a clinician scientist. So because it's more than just doing the research, it's actually being in an environment where you have that institutional support to do that. And then there are, so moving from the kind of the resident research grants and funding mechanisms, then there are these K awards, which are really kind of transition to faculty awards. And they're I just listed the ones that are relevant for neurosurgeons, for neurosurgeon clinician scientists. And so there's the K99 to R00 award. And I'll talk a little bit about that. The K12 is actually a national neurosurgery K award program. And actually they're only, within NINDS, there's only two of them. There's one specifically for child neurologists, pediatric neurologists, because they're a dying breed. And the other one's for neurosurgeons. So, and this was, actually was involved when this was started, about a decade ago. And this was started specifically to foster basically a growth in neurosurgeon scientists, because there was just so few of us that it was felt that this was going to be, we were going to be dinosaurs and dying out unless there, we had a handicap. So this K12 award is a K award that's specifically for neurosurgeons. So you're not competing with the neurologists, the psychiatrists, or any other subspecialists within around the country. There's also the K08 award, which is a mentored clinician scientist award, as well as the K22 and the K23 awards. These are open to everybody. It's not just neurosurgeons, it's really any physician scientist. And I'll go through the difference between a K08 and a K22 and a K23. A K22 is really just an intramural award for the NIH, for the NINDS. So those are for people who specifically are going to be working at the NIH. So I'm not going to go into the K22s too much, but I'll talk about the others. So so some of these, I'll just go through and feel free to ask questions afterwards if you'd like. But the K99 to R00 is a Pathway to Independence Award. So this is actually, it's very competitive, but it's actually a great award to really kind of foster that transition. So there's two components to it. It's a 5-year award, but the first 2 years, the K-99 part, is a mentored research fellowship that is, that you could do during your clinical fellowship. So it's usually, it requires a 50% commitment of time to research. So it's like a 50% research, 50% clinical commitment. And, to really be able to start your kind of research career during that fellowship time that, nowadays most neurosurgeons do post-residency fellowships. And research is no different. Research is, in order to be a clinician scientist and make a career in this, I do think you do need further training beyond just the 1 year or whatever is kind of provided within residency. And then the next 3 years is the R component, and that provides independent funding, about $250,000 a year for 3 years for those initial 3 years of your faculty appointment. And if you get one of these, it actually makes you very competitive for faculty positions, because as you can see, you come with your own funding, which is actually a very good thing. And the next K award that I'm going to talk about is the K-12 Neurosurgery Research Career Development Program. And this is a national K award. It's actually agnostic to institution. It's really looking at kind of the national pool of neurosurgeon scientists, and then these awards are given to individuals regardless of which institution they go to. But they are essentially supposed to be early transition to practice types of research awards. The applicants need to have an offer for a faculty appointment within the first 2 years of their faculty positions. So it's a little difficult to get this as a resident if you don't have a job offer yet. So you actually need to have a job lined up or a commitment from the institution that's going to take you on as a faculty member. The time commitment is similar to all the other K awards, is 50% time. And it could be basic science, translation, or clinical research. NINDS has always had a 50, or not always, but I think it's been 10 or 20 years now. It's been a while. They've had a 50% time commitment requirement for neurosurgeons. All the other institutes, unfortunately, were at 75%. So you actually had to do research 75% of the time. Just recently, the NCI actually lowered that requirement to 50% for surgeons. So I think more widely, regardless of which NIH institute you apply to, I think it's becoming recognized that 50%, for a surgeon is probably more reasonable. And then, to get one of these grants, as I mentioned, you actually do need to have a faculty appointment and institutional support from the department chair. And then there are individual K awards, and these are usually K grants that you don't get until you've kind of been at your faculty appointment for maybe a year or two and have some preliminary data and are ready to kind of start your research project, but you're not quite yet ready for an R01 or an independent award. So there are two main mechanisms whereby you could get a K award. One is a K08 and one is a K23. As I mentioned, there's also a K22, but that's an intramural award specifically for the NIH. So the difference between a K08 and a K23 is really the type of research. So if you're a basic science PhD type of person and you want to do kind of more basic translational lab work, the K08 is probably more appropriate for those kind of projects and those kind of people. Those are, the K08 is a clinical scientist development award. Usually to get one of these awards, you probably do need basic science experience in the lab with some, publications in the area that you're proposing to do research in. And you also need to be within 5 years of completing your clinical training. So you can't be, a full professor and applying for a K08. You actually did, this is specifically designed for people in their first 5 years. The K23 is very similar, but it's not for lab research per se. It's actually more for patient-oriented research. It's a patient-oriented career development award, and actually at our place, our functional neurosurgeons, tend to get these because they do a lot of their research in patients, as well as vascular and spine, because a lot of things like device development, development of new technologies, kind of clinical trials or therapeutic interventions are more tailored for these K23 mechanisms than they are for the K08. And then, things to look for as you transition from residency to a career as a clinician scientist. And these are some important factors I think you should look for in terms of job opportunities. Departmental resources and local collaborations. As I said, it's hard to do research in a vacuum. You actually do need an environment where there is the kind of not just the departmental support, but probably institutional support, where there are other people to collaborate with and do projects with. And nowadays there's a lot more crosstalk between, for instance, the biomedical engineers and the basic scientists and the molecular biologists and the bioinformatics people, and that whole environment within wherever you take your position is very important. The amount and length of support is important to think about, and probably more important than anything else is really the track record of funded faculty in the department that you're joining. If no one else in the department has ever had an NIH grant, it would be more difficult for you to get one, simply because you don't have the mentorship and really the infrastructure to help you, for instance, in applying for grants. In our department, we have a lot of fund managers and grants officers that work on all these little components of how to apply for an NIH grant. So having an environment where you feel like you could be set up to succeed is very important if this is the route that you want to take. Like I said, not all residency training programs or neurosurgery departments have all of these components, but not all of them have the mission of training clinician scientists. So it's really a matter of matching what your career goals are with the institution and the resources that are available to you. And I just wanted to end with this last slide as to, well, why do all of this? Why become a clinician scientist? And it's not really to, say that you're a clinician scientist or you're doing research. The goal is really, in my mind, is to translate your research, your ideas, what you think could be helpful to patients, to translate those basic science discoveries to clinical trials and to human applications and human treatments. And this is just an example of kind of what I do in my day or my week. I do have a basic science lab, and we study novel oncogenes and mechanisms of gliomagenesis and kind of more mechanistic studies. When I started out, I had a K08 award, and started hiring postdocs and lab techs, and now the postdocs are now professors and collaborators. But we have a very dynamic group of people that just study the basic biology of brain tumors, and then translate that to translational preclinical animal studies, and then eventually to clinical trials. And several treatments now have kind of gone through this pathway from the basic discovery all the way to phase 1, 2, and 3 trials. And Dr. Barker will talk a little bit more about kind of the whole clinical trial component of research. And then I think what's really interesting is when the treatments or the trials and interventions, work or don't work, taking that information and then getting it back to the lab and studying it again, whether it's, by collecting the tumor tissue or by, recording the recordings in terms of, depth electrode placements or whatever it is that your research is focusing on. I think to be a successful clinician scientist, it really would be most efficacious and beneficial if your research actually matches your clinical practice. I think it would be very difficult to, do research in brain tumors and be a full-time spine surgeon. It just would not really mesh. And the reality is the reason that the NIH is giving funds to neurosurgeon scientists is because as a clinician in the field that you're in, whatever disease state that you're treating, you should hopefully have some insights into the disease that you could take back to the research lab that someone who isn't a neurosurgeon, who just has a PhD, can't do. And that's really the advantage. And that's the reason that I think the NIH is funding neurosurgeon scientists is not because you do this very well. It's because you could actually combine all of this. You could combine not just the basic science, but also what you see in your patients and then take it back. So I will end there and turn it back over to Dr. Johnson.
Dr. Liau, thank you for that. Excellently tailored and concise, but very, very informational. I appreciate it. I was going to give the panel a second to ask a quick question before we introduce Dr. Barker's talk. I'm not sure if anyone had any burning questions to ask now, or if you want to do it later, it's fine. All right, in that case, we're going to go to part number 2, Dr. Barker. We wanted him to kind of focus a bit more on the second aspect that Dr. Liau mentioned, which is taking ideas from research and studying them in humans, and some of the issues surrounding that pathway, things that neurosurgeons can do to help advance the field and treatments, et cetera, for patients in that scientific realm. That was, I asked Dr. Barker to go ahead and share his slides.
Can you see that?
Yes.
Let's see. Right to the beginning here. All right, so I think my career path was, Linda Liau is a much more organized person than I am, and probably could have told you when she was a resident just what she would be doing at year 5 and year 10 and year 15 and year 20. I didn't have that good an idea. In fact, I don't think I had ever seen anybody have a career quite like what I ended up stumbling into, but I've since seen many other people pursue this, and it is a little bit different. And that has its advantages and its disadvantages, as I'll try to show a little bit. I think the year 2020 showed us that life without clinical trials is like the life unexamined. I mean, vaccines work, hydroxychloroquine does not work, and no amount of misinformation from whatever source, the most powerful person in the world, that just cannot stand up to this. And it's the same thing in neurosurgery, except that we have so few clinical trials. Only about 1 or 2% of our literature is actually randomized clinical trials. And although that has inched up a little bit over the years, particularly I think in spine, it really has not exactly rocketed up. Less of what we do has a secure foundation in clinical trials than for many or most medical specialties. And yet when we do a clinical trial that's successful, it really moves the needle very quickly, not just within the US, as in this example, there were 2 positive trials of mechanical thrombectomy for stroke published in the New England Journal, I think in the same issue in March 2015. And the number of patients treated with this methodology doubled in about 6 months. And the number of hospitals offering the treatment increased about 50% over a year. Same thing when the carotid endarterectomy trials came out that were positive in the early and mid 90s. Even before the articles were published, just the presentation at meetings the number of patients who received the treatment even went probably a little too far, and that patients who might not have actually benefited were kind of squeezed into the operating room for this. So if you want to make a difference in the world or in people's lives, this is a very good way to do it. And on the other hand, when trials are done regarding things that we think are our territory or are important to us, like AVM's, the Aruba trial, which was designed and conducted essentially 100% by neurologists, there's a risk that we can be very unhappy with the results. And it results in editorials like this that say that the study is flawed, the results are not applicable, serious flaws. And I think most vascular neurosurgeons really considered this to have been a waste of about $5 million of the government's money, and actually a source of, in many ways, misinformation, because the design of this was really not competent. So what are the, I guess Linda made me think, like, why do you do it? She waited all the way till the end. I thought maybe I'd try to sneak it into the beginning. I mean, my dream when I was a resident was that I would someday stand up in front of the AANS and announce that we had found the cure to glioblastoma. And I not only am not going to be that person, but I might not even live to see that person's talk. But I've kind of gotten over that. But what I realized after I realized that I was not going to have a career in bench science, which was a big disappointment to my father, who was an academic surgeon who studied diabetes with islet transplants all his life. I realized that that dream was not about working in a lab. Actually, that dream was about conducting a successful clinical trial. And I have since had that experience several times. And you really never forget that experience. That is an experience that nothing in your personal life, and not even doing a really good operation, is the same kind of thing as that. They're all good, but they're all different. So when you decide that you're going to make clinical trials your main focus for your research interest, the first thing is that nobody but us does these. There is not a universe of people with a degree that you don't have who has all day, every day to think about this and do this. When you're doing bench science, there are always PhDs who did their postdocs in the Nobel Prize winner's lab who are competing with you for the same grants. And in the clinical trials world, you just don't have that. And I think that makes it easier for us. And secondly, there are no neurosurgical operations that require knowing how to do PCR, but a lot of neurosurgical clinical trials require neurosurgeons to actually deliver the treatment. And it helps, if you're going to run those trials, to be a person who also knows how that treatment is delivered and to be good at it, so that you know the issues that your colleagues are going to run up against in doing that trial. Dr. Liau talked a little bit about the various grants that you can get at different stages in your neurosurgery career, and most people have heard of most of these grants. But these are not much help to you if you want to go into clinical trials research. The K-12, the 19 awardees over the 7 years from 2012 to 2018, 0% of these were for clinical trials. They were all for basic research. So the government is not falling all over itself trying to help you with your career. And so you're going to have to, as one of my colleagues said after the aneurysm ruptured, Lord, if you're not going to help me, I'm going to have to do this myself. And that kind of applies here. The NIH is not staying awake at night thinking about you. Compared to laboratory research, modern clinical trials are quite complicated and much more expensive than many people realize. The timeline both to acquiring funding for a clinical trial and to completing that trial is a long one, and some trials are never completed. And when you finish your residency, it's likely that you will not have the track record with clinical trials that your colleague who's going into the lab will have with lab research, particularly if he or she has a PhD. And finally, the department chair that you're talking to, who's going to set up the support for you for your first couple of years, is probably a lot less familiar with setting up a career for a clinical trialist than they are for setting up something for a newly hired lab scientist. So if you think that to start an academic job at a leading institution, you might need $1 million or $1.5 million startup package, What do you ask for if you're going into clinical trials? That's a lot harder to say. I see Dr. Liau smiling. It's probably 2 million at UCLA. I said that they're complicated. If you are handed a trial, and this trial is going to be open at 20 centers, can you open this at your center? It takes an average of about 7 months to get that trial open at your center. And there are an average of 110 steps to go through to do that. And if you want to write your own trial, the timeline is quite a bit longer. I took this graphic and cut it into pieces from a JCO article. This graph printed out at 8-point type size is 12 feet long, and it involves 317 steps between when you get your idea to when your protocol is ready to open, and an average of about 2 years. And that is with the support of a national clinical trials group. So you're going to need help, and you're not going to be able to tell your new chair that within 2 years you're going to be publishing your first trial. That's just not realistic. Modern clinical trials are expensive. I don't know what the average R01 pays these days, but people think, well, I'll just do a quick pilot trial. I'll get the department to pay for it. The average phase 1 trial nowadays for a central nervous system drug is almost $4 million. A phase 3 trial weighs in at about 20 million. And those are drug trials, and many surgical trials are more expensive because somebody has to pay for the procedures or for the inpatient admission. So you can't just be casual about this. You have to figure out who's going to pay for it. And just as with bench research, that's a big and complicated field. And it starts out with just thinking, well, what's my area and who are the possible funding sources? For many of these, there are possible support from private philanthropy or from patient support foundations, but the amount of money is really prohibitive for a lot of clinical trials. And so it boils down to NIH or industry. In tumor, you're dealing with the National Cancer Institute, NCI. Spine has a real problem because from the NIH's standpoint, it falls between the musculoskeletal group, where you're competing with hip fractures and knee fractures and ankle repairs, and NINDS if you're interested in spinal cord injury. And NINDS is largely really not interested in degenerative spine. Really, none of them are. PCORI, which was started during the Obama administration, is really has an aim to treat the most common diseases with pragmatic trials on tight timelines. And that is how I have seen some spine trials get funded. And of course, industry is very happy to pay for a trial that tests their device. But if you want to test an operation that isn't restricted to a single device, industry has no interest in that. Same with vascular, particularly endovascular. A lot of device trials supported by industry, and now a lot of stroke trials supported by NINDS over the last decade. Functional and also pain, if it's a device trial, industry will support it all the way through FDA approval. And NINDS has a special unit called NeuroNext, which is a network of centers that do phase 2 trials, which are the smaller trials that precede the randomized trial. Trauma, there's an NIH entity called Siren, which isn't just limited to brain trauma, but also supports brain trauma trials, and industry, again, particularly if there's advice, but also if there's a drug. And pediatrics, for pediatric tumor research, the NIH supports it. Otherwise, I'm not sure who does. I guess the developmental branch must support some of this, but there's actually a private network that does a lot of this. How long does it take? You want to tell your prospective chair, well, I'm gonna open my trial in such and such years, and I'm gonna finish it and report it in such and such a time. Well, this is Zoe Gogawala's first trial. He and I designed this in 2002. I still have the files from then. Wasn't published for 14 years, but it was his first clinical trial, and it was published in the New England Journal. And he did it all on philanthropic support, really on a shoestring, a real accomplishment. Here's a trial that Tony Asher wrote with Stuart Burry in around the year 2000. It was opened through a cooperative group that then got closed. It was then opened by a second cooperative group and then got folded into a third cooperative group. And by 2015, it was finished and was one of the 4 papers presented at the main plenary session for ASCO that year. again, designed by a neurosurgeon and conducted largely by neurosurgeons, and now been published for 5 years and has 800 citations, a very successful result. More people don't do this, though, because it takes a lot of time and a lot of support, and not everybody has that available to them. Here is sort of a rough outline of the life cycle of a clinical trialist. When you're a resident, you're lucky if you have very much exposure to clinical trials. You might get consent, but in not every institution is anybody but the investigator even allowed to get consent. You might have some exposure to collecting the data or even to analyzing it, but for myself, I had none, zero. In fellowship, it's likely that you will have the opportunity for intensive exposure to clinical trials, almost no matter what area you're in. Possibly skull-base might be an exception to that. And if you're interested in this is the time when you really need to go out and get it and tell the people who are in charge of your fellowship that that's one of your major goals, and make sure you accomplish it. Then as a staff member, you can join one of the clinical trial groups that we will talk about. You attend meetings where other people present their trial designs. You have an opportunity to criticize them and hear other people criticize them, see what succeeds and what doesn't. And this is where I probably did, at least half of everything I've ever learned about clinical trials, the remainder being reading other people's clinical trials in journals and papers about trial design. And then the next step up the ladder is designing your own trial, conducting it, analyzing it, and reporting it. And finally, joining these groups that sort of oversee other people's trials, like the National Clinical Trials Network group, of which I'm the vice chair of one of the groups for surgery for brain tumor trials, or the Brain Malignancy Steering Committee, which is the NCI group that gives the no-go or go decision for all large federally funded brain trials. That was a fascinating education. I did that for 6 years. How about formal instruction? All of us went to school for 20 years. Can't you go to school and learn this? You can. They're at the hospital level, at the university level, at the level of your professional society, or at the level of your clinical trials group, your NIH supported clinical trials group in your specialty. You can get this. Some people go ahead and do the full-on 2-year MPH. I have not seen that be very helpful. It is not the case that like when you see somebody who has a PhD after their name, almost certain that they've designed, conducted, and analyzed actual bench research. That's not the case for these MPH or clinical effectiveness degrees. They don't get you as far, and I don't know very many people who have got them who have built big careers in clinical trials. Here's an example at the hospital level. This is my hospital, Mass General, a 1-hour course in writing a protocol. All right, that is going to teach you what kind of word processor to use, and make sure you spell everything correctly, and not much beyond that. That's just not enough time. But a 1-hour talk about dealing with your local IRB, now that's valuable, because local IRBs are very different one to the next, and there's no other place that you're going to get that information. Here's the Harvard School of Public Health summer program in clinical effectiveness. I never did this, but I think it's a valuable program. But again, it's not like a go, no go thing. Here are some things that have been really very successful. This ASCO AACR, that's the American Society for Clinical Oncology, which is the medical oncologists equivalent of AANS or CNS, and AACR, which is the main bench science in cancer research society. In about 1995, they put together a clinical research workshop, and this is the pattern for almost every similar one that's come out since. So you submit an idea for a trial protocol. They select 40 people or 60 people who are going to be accepted into their course. The course is a week long at somewhere like Vail, and they turn off your phone and don't let you have access to the internet. And the goal is at the end of that week that you will have a fully written protocol that is ready to go. And that picture on the bottom there is the first class of that course. And if you could blow that up, you would see Suzanne Chang in the middle there next to John Sampson and Tom Mickelson. And if you're interested in brain tumors, you will know that within about 5 years, Suzanne Chang was the president of SNO. And within about 10 years, John Sampson was running a phase 3 clinical trial and chairman at Duke. And these can be very successful. SNO has a course that was basically copied off of this, very similar to it, and this year will be given jointly with ASCO. The advantage here is that you can view the didactic sessions, which are now archived on the web. And they also run the same thing where you submit a trial protocol and then end up with a fully written trial with limited enrollment. And that will be done again this year, virtually, of course. And NINDS has similar options for people who are interested in stroke or trauma or NeuroNext, which is mainly for functional research. And again, you submit a trial protocol idea and you write a trial. This is a slide I got from Sepi Amin Hanjani about sort of on-the-job training as a clinical trialist, which is really about the only kind there is. So you need to learn the regulatory aspects, which are as boring as anything that I've ever seen a talk on, but very important. Design and execution of clinical trials, which is what I think is really fascinating, the design. It's a different way of thinking. It was something I had never been exposed to until I did my second fellowship, which was in a medical neuro-oncology clinic staffed by oncologists, and they just think differently. And it takes a while to learn how to do it. And then managing the people who will be collecting your data, the nurse practitioners who work in the unit and handle the calls from the patients and so on. And the key ingredient here, as Dr. Liau said with bench research, is a local senior clinical trialist who knows how to do all these things and can make them possible for you. And your short-term goal should be to get to go to these meetings of the clinical trials groups, either meetings focused on an individual trial like Zogo Glawala used to run at the AANS or the CNS for investigators in his spine trials, or a national group like the RTOG or the Alliance Clinical Cancer Group. And meeting these people, you know, when somebody opens up a new randomized trial that they want to recruit 20 centers, they don't have Olympics to see who's going to be those 20 people who are going to be the local PIs. They're going to take their best guess based on how they know the field at who's going to be able to help them complete the trial, meaning who's going to be able to enroll patients to it and who's going to be able to work as part of a team and not, for instance, cheat to get people into the trial who aren't really eligible for it or try to subvert their randomization, all of which I've seen. And your first steps in here, it can be an actual clinical trial or even a prospective registry. It's very easy to get involved in registries. Your department has to pay for it. You don't bring money in, you send money out, but it's very easy to get involved, and it can be the easiest first step. As a resident, as a fellow, as an attending, there are your short-term goals, which I think I've already gone over a little bit. And your goals want to be to accrue patients and to have your data not be a problem for the primary investigator, because there's going to be audits. It's not an indicator that they think you've done something wrong. It's just a routine part of the process. And you don't want your patients getting thrown out. You don't want violations that are going to be difficult for them to explain to the people who are overseeing their trial. And the funding, if it's available at all, may come in a package for each patient that you accrue. So if you accrue 5 patients, you get paid after they're done. And in general, that money is not enough to support what your institution will spend on this. So this is one place where your prospective chair can offer you some support, that they can pick up the slack, which may be necessary, you know, for a period of time here, the institution needed $10,000 for every patient enrolled. And the cooperative group was only offering about 5,000 or 8,000. And the department chair had to make up the rest, or the investigators' sundry funds or philanthropy. So there's a place where you can tell your chair that you may need support. Here are some registries you can get involved in. There's the NeuroPoint Alliance, which is run by neurosurgeons and has registries for tumor, for spine, for Parkinson's disease, or NSQIP, which is a very general national registry for craniotomies. If you can't find something like that, you're going to have to go to clinicaltrials.gov and look for clinical trials in the field that you're interested in and take a look at them, see who is funding them, see who is running them, see if they're going to be interested in opening another center, which many of them are, see where they are in terms of accruing as many patients as they need to complete the trial. Existing research networks, this is really sort of the heartbeat of clinical trials for the neurosurgeon. And I've listed them here for each individual topic that neurosurgery residents might themselves be interested in. I'm really going to talk just about the one I'm most familiar with, which is the National Clinical Trials Network, but they all share a certain amount of resemblance. This is how this works. This is what used to be called the Cooperative Trial Network, Cancer Cooperative Trial Network. You look over here, you see that the United States has decided that every year 151 million are going to get spent on this. Now, what happens is it gets divided up between these 5 cancer cooperative trial groups. One of them is pediatric, the other 4 are adult, and they really are very similar one to the same. The SWOG is Southwest, ECOG is Eastern. This has a little radiology piece. This has a radiation oncology piece. So each of them roughly gets $30 million a year. And then they have 2 meetings a year and they decide how that $30 million is going to be spent. If you go to that semi-annual meeting, you will go to, if you're a urologist, you'll go to this GU surgery committee where actually prostate cancer and bladder cancer trials are discussed. But then if you want, you can go to the experimental therapeutics meeting that talks about all kinds of new cancer drugs. If you're interested in disparities, there's a committee for you. If you want to learn more about statistical design, there's a lecture, there's a plenary session, there's a core labs committee. There's a committee that for some reason is people who are interested in auditing other people's data, which you are almost certainly not interested in and do not want to do for yourself. And so you're going to hand that off to this committee and it's going to be out of your hair. There's a data safety and monitoring board. You don't have to design your own. You don't have to get 5 people to do this who will not be authors on the trial or be compensated. Good luck with that. There's an imaging committee. So a lot of things that are really necessary for a well-run clinical trial that you may not want to do yourself, they will do for you. And here's the real crux of it. When you write a protocol that is going to be run through one of these committees, it's going to get run by a lot of people at a lot of different hospitals, and you do not have to write a grant. All you have to do is convince the committee that your trial is worth doing. Your group chair will bring it to the group scientific chair. It's likely that it will happen. If it's really expensive, it goes through one more layer of oversight, which is stacked in your favor, staffed almost entirely by clinicians like myself. I did this for 6 years, and improves the design of your trial almost for sure. And then you can start thinking about the next trial. While the group mechanism is conducting your trial for you, you can think to yourself, what if my trial is successful? What will I want to do next? Think about a proposal for that. What if my trial is not successful? And if you run a bunch of consecutive unsuccessful trials, as glioblastoma clinicians know all about, you can take all the tissue that's collected and do an analysis over multiple trials. You can analyze prognostic factors. You can really squeeze the stone and get some blood out of it, even if all the trials are negative. Now, lastly, I'm going to give one example of how an idea moves from the lab to a clinical trial. This is started out at Harvard at Dana-Farber by Priscilla Brastianos, who identified the BRAF V600E mutation in virtually every papillary craniopharyngioma. Now, this is a mutation of tremendous economic importance because it's about a half or a third of melanoma patients, metastatic melanoma patients. And so the pharma industry has been working on this like crazy and has some very successful drugs for it. By the end of that year, we had treated our first patient. This was this patient's 5th recurrence after multiple operations. He was an illegal alien from another state, and it had proved impossible to get him any radiation treatment for this. And so it came back 4 or 5 times within a single year. Finally, we just sat him down in the hospital and started giving him these BRAF and MEK inhibitors. We took tremendous heat from the hospital because it's an oral medication. Why is this guy in the hospital for a month while you give him pills? We ignored them for as long as we could and found that the tumor nearly completely vanished, 85% volumetric response with no toxicity in about a month. So we reported that out at the AANS meeting and in JNCI, a pretty good journal. But we wanted to do a national clinical trial in this. So Priscilla wrote the protocol. It's a straightforward single-arm phase 2 protocol using commercially available drugs. We had trouble at first getting support, getting the drug from the original company, and we had to go with an alternative drug from another company. Then, like Ian Parney here, shown in front of the Alliance Committee, you stand up and you present your protocol. You get constructive comments from the roughly 100 people in the room. You go through a cycle or two of that revision. And then, as if by magic, it's opened at 91 centers in 26 states across the country. It was opened in 2017. It's a rare tumor. You could never do this at your own institution, really, no matter who you are. And by about the same time of year last year, the accrual was completed. We now have the 6-month follow-up, and it will be reported at ASCO in June with the abstract online in May. So a drug that the information is embargoed, but this is a home run and has always appeared that way. Took 7 years to get from the bench to the bedside. And it's still not, will not be FDA approved until further work is done. So when you go to your prospective chair, do not promise the moon. Give them a realistic idea of where you are in this life cycle and what you need from them to get you to the next step. And then good luck. And so I'll thank the people who helped me with these trials and with slides for the presentation. And happy to take any questions that you might have.
Dr. Barker, outstanding. Thank you so much. I just want to note that it seems like Dr. Liau may have lost her internet connection, so see if she can make it back. If not, we'll have to man the questions without her.
I'll answer for her.
Yeah, you're gonna have to be the person that takes all the shots. I just want to give our panel a second to ask any questions, thoughts that they may have before we get into the question and answer. I'm curious to hear what everyone's feedback on. There's a lot of information, a lot of complexity, but we want to be strong academics and move our field forward as young neurosurgeon leaders. So I just want to get people's thoughts. Maybe I like to go through seniority. So I think in this case, Dr. Bentley is probably most senior. Any thoughts or input that you would have?
Yeah, I just have a burning question. First of all, thank you very much. This is an excellent presentation from both. My question is about time and effort. It's a recurring theme, the time commitment if you're going to become a clinician scientist. So I was wondering if you could give a perspective on how you structure a typical week, and if you could do anything differently. Do you have any advice for how you would have done something different?
Well, one reason I think it's hard or different clinical trials work from bench science is there isn't necessarily anything to do on a given day. So if you're thinking, can I do this for my 2 years research experience? It's very hard to say what you would do all day, every day. And maybe you might take some courses, you might, but you're not going to sit down you're not going to get up at 7 in the morning at the hospital and start writing your protocol and be done by 9 o'clock that night, and then tomorrow move on to the next protocol. There are a lot of times when your protocol is out of your hands, in other people's hands. They're reading it and deciding whether it's okay or giving you input about it, or you're waiting for somebody to write the statistics part of the protocol or something like that. So the more different things you have going on at any one time, obviously, the more you can use what time you have available constructively. And there are always other people's trials that you can spend time reading and thinking about how you would have done it, how they got it done, what the flaws are that you would like to avoid, how they got the funding that allowed them to do it. So today, for example, I spent my time preparing this talk, and that was and talking with Priscilla for about 45 minutes or an hour about our plan to analyze the data, what journal we're going to target for 2 papers that we're going to be writing, one on her meningioma protocol and one on her craniopharyngioma protocol. Next week, she will get the data back from the statistics group at the Alliance, and we will probably start spending a significant time each day writing the paper. And when you're dealing with these high impact journals, actually my experience has been to expect about 7 or 8 rounds of revision at the journal, the first round of which is maybe 5 or 10 pages worth of points. I think Zoe's recent trial, I think on the 3rd go round, there were 120 points that they wanted addressed in the manuscript. And he had 1 week to get it back to them. So it goes in sort of bursts, depends on when the data comes back to you and it gets into your hands. And it's not a regular amount every day. So in a way, if you spend the entire day, as I did yesterday, doing a huge case and then dealing with the aftermath of that, it's not a big deal. You know, it's much more flexible in terms of how you can spend your time. And you can get stuff done after the kids go to bed, or after your spouse goes to bed, after everybody goes to bed, or if you're a morning person, you know. It's easy to take little scraps of time, which is harder for bench science. If you're going to run an experiment, it's going to take a certain number of hours. And if you have to drop the ball in the middle of that, that may ruin the whole thing, and you have to start over from scratch. That really doesn't happen with clinical trials. It's much more flexible.
It's a great conversation. I think some of the bottom line of all this is you have to have a lot of patience, no matter which route of these you go, to kind of parallel clinical practice as well as the scientific endeavors. It's a lot of work, but very rewarding, I imagine.
Well, it took us all 7 years to learn neurosurgery. So, I mean, I think people, I have seen bench researchers, and I'm by no means talking about Dr. Liau, is really the opposite of this, but who think, well, the hard part's done. You know, we've cured these mice, and I can just hand this off to any junior faculty person, and they will carry this across the finish line for me. But that, I don't know if that ever worked, but it does not work in 2020. I mean, there are just as many pitfalls in getting a good idea that really ought to work to actually demonstrate its value. And you need the people who already know how to do it to show you how to do it. And step 1 is finding them. I mean, a lot of these vaccine trials and hydroxychloroquine trials and so on that were done in the last year, ID doesn't do this kind of thing. You know, they don't try to do a 100-center trial. You know, industry may have that experience, but hydroxychloroquine, there was no industry behind it. And they reached out to the oncology community because they're experienced in putting together networks and getting data that is analyzable out of hundreds of different centers. And you know, you have to work as a team. And that's another thing that is not necessarily the native language of a prospective chair, that you're going to be part of a team. You know, team science and neurosurgery are 2 very different things in a lot of ways. And if the focus is on how are you going to bring in the funding, you need to restructure the conversation into, you know, what are reasonable goals for you to achieve, and what do they need to do to help you to get
That's great
there.
advice. While we have her back on, she's reappeared. If Dr. Liau has connectivity, I wanted to ask one question of her that kind of bridges her talk and your talk, Dr. Barker, and then we'll let the rest of the panel chime in, which is what was her experience translating her own research into clinical trial, phase 1 and beyond, and how did she go about getting the mentorship that Dr. Barker mentioned needing to kind of create you know, a meaningful clinical trial out of a new scientific idea. If she's not able to.
Yeah.
Happy to answer.
No, sorry about that. I lost my internet connection. But I could hear you guys on the phone. So I guess, yeah, in answer to that question, I think it's like, when I got my first IND, I think it just has to do with rolling up your sleeves and jumping into it. I'm not sure there's any textbook or, specific class or mentorship that you could actually do. And I must say the FDA regulations, IRB regulations, the ISPRC regulations, they also change over time. So it's one of those things that, depending on what institution you're at, or what administration's running the FDA at the time, it's a process where I think at any point in time, if that's what you want to do, I suggest just jump into it and then find other people who have done it and get their advice and try to run with it. But I think you do need to just jump in and do it, because if you don't, it's really hard to get that experience without having done one.
Very good. So I think, Neil, you may be next on our seniority ladder. Any thoughts or questions you had for our distinguished speakers here?
No, those are both great talks, very informative. A lot of the times we look at these grants, and Dr. Liau touched on them, it's just like alphabet soup. So I thought you clarified them very well. And I like the way you gave us a timeline of what sort of grants to look at as a resident, and then as you move forward to your career. A question that I had was, a lot of the times you mentioned that there are X number of programs in the country that foster a resident to become a clinician scientist. Many residents across the country are not at those institutions, and if they do have an interest in either bench work or clinical trials, how can they position themselves as they move forward in their career to follow that career path if they don't have those resources available to them at their home institution?
Yeah, no, that's a great question, and that's actually why the K-12 program was started. Because that's actually a national kind of K award program, so that you do get kind of a group of people nationally that you could turn to for mentors and for advice, and I've been on that kind of advisory group for almost a decade now, and so I have mentees who are junior faculty at other places that have luckily gotten K awards, and they're not necessarily at places where they have people within their institution that have gotten NIH grants. But I think neurosurgery as a community is
I'll finish that. Is that a happy group of people who get along and are helping people?
Dr. Liau, if you can hear us, you froze a little bit there, and Dr. Barker finished your thought for you. Hopefully we get her back. All right, Jasmine, I think maybe you're up in the meantime. See what are your thoughts? Any questions? We have a lot of questions and answers here.
We do, yeah. I just, first of all, thank you very much. I mean, this is extremely informative. I feel like a lot of this information is hidden in various websites and different places. It's very difficult to sort through as a resident. So I really appreciate you guys distilling this, and I'm probably going to listen to this lecture yet again later. But I guess I had two really quick questions. The first one was there ever a turning point for you, Dr. Barker, and I guess if Dr. Liau comes back on the phone, that you realized, this is what propelled my career as a clinician scientist. This is what allowed me to kind of continue on this path. And then the other thing, as I'm getting closer to the end of my residency, is there anything specifically that you requested for or looked for in your first attending position out of residency or out of fellowship that was particularly helpful for you, or anything that you maybe wish you would have asked for at the time?
Well, I got nothing. I didn't even get my moving costs paid. And after 3 years of fellowship, the coffers were dry, I can tell you. I made less money each year after I finished my residency for 3 years. And until my wife got an actual paying job, it got, there's a famous story about our first Christmas in San Francisco where we didn't have enough, we had spaghetti. So I think what I could have asked for would have been a commitment, on paper to support me with things that I didn't know until I got there, what I was going to need exactly. But in terms of hiring a clinical research coordinator, a CRC, to help you get things through the IRB, to help you with data management, to keep you out of trouble, somebody that you identify at the institution, and then ask them what you should ask for, because it's a little hard to know what's there in the department already that you can just use a fraction of somebody else's FTE and what you need yourself. If you say what was the moment when I knew that was what I was going to do, I kind of found when I was a resident that I was really interested in statistics. Like, most people go to the AANS and remember seeing Spetzler clip and aneurysm, but I can tell you about the time I saw a poster that used logistic regression, which was the first time I'd ever seen such a thing. I couldn't imagine how you could do regression analysis on a binary variable. And then more and more, I found that there were areas of statistics that had not been applied to neurosurgery, where there were interesting questions that could be analyzed that way. And then I got to Pittsburgh, and they had prospectively collected data on about 4,000 MVD patients, and nobody had analyzed it. And so my wife was still in the Air Force at that time in Boston. And it was pretty much neurosurgery camp for me. And I just spent the year analyzing their trigeminal neuralgia series and their hemifacial spasm series. And then that was one of the first, 2 or 3 papers I wrote. It got into the New England Journal. And at that point I said, actually, this is a lot of fun. And then around the year 2000, I saw presented at ASCO. So imagine a big dark room like AANS with 40,000 people in it. An enormous room. And I saw the randomized trial of Gleevec, which is imatinib for CML. And the prior treatment for that was bone marrow transplant. And they got up and they showed Kaplan-Meier curves where the imatinib patients, 100% were alive, and the bone marrow transplant like that. And then the toxicity was just blown out of the water. And the bone marrow transplant specialist got up and said, I've made my career in bone marrow transplantation, and I'm here to tell you that this is now the standard treatment for that disease. That was the first targeted treatment for cancer. And I said, why don't we have this? This is a tremendous feeling to see these people succeed like this. They've hit a home run that was beyond anybody's wildest dreams. And the guy who discovered that drug found it as a fellow at the Dana-Farber, and they didn't keep him on staff. They judged that he was not promising enough to keep him on staff. And he was the one who reported that trial from Oregon. And so I said, that looks like something that that nothing could really replace. And is there ever a time when I've regretted it? Well, I was telling my daughter, who's now interested in medical school, there are 2 times when I've seen somebody else's career that I really thought I should have done that instead of what I did. And one was Fred de Savage, who was a guy who finished his medical oncology fellowship, went to work for Genentech and invented vismodegib, which is the first drug in the hedgehog pathway, and makes basal cell carcinomas just melt away. And I said, that's what I should have done. And then I met the guy who ran the World Bank, who was an MD, who delivered highly active antiretroviral treatment to sub-Saharan Africa, probably saved 50 million lives. So short of those kind of things, there's nothing you could do in neurosurgery that will save 50 million lives. It's almost impossible to imagine, but it's the same sort of feeling when you see the first patient recover hearing from an NF2 acoustic, or the first patient whose craniopharyngioma is just gone because you gave them some tablets. I mean, that to be the first person to see that is really exciting.
That's great. Any other thoughts, Nicole or Jasmine, or questions that you have? If not, we can forge into the question and answer section. Got like about 5 to 10 minutes left here.
Dr. Liau, I had a quick question for you as a chair of a department. What are you looking for in your new hires, your new faculty hires in terms of clinician scientists? Like, what's the one thing that they really have to have? Is it a vision for their future? Is it, a grant already under their belt? What are you looking for?
Yeah, someone who could fix the internet, but
Where's Dr. Berkshire?
but the one thing is really it's really the passion, the basically the why, and really kind of wanting to change our field, wanting to develop new treatments that we don't have yet. And I think actually, Fred, 30 years ago, I mean, my goal in life was also to cure GBM. And unfortunately, I think we'll both die before that happens.
Don't say that.
but maybe someday, but I think I think looking for people who don't just want to come to work every day and just, do a bunch of cases and go home. It's really kind of the person who wants to really, change our field. And I know that's kind of a vague, broad answer, but I think that's really, as an academic, medical center, that's really our mission.
Really great answer, I think. I'm just going to try and hit a couple of these questions quickly. I'm not sure how many we can get through in the time we have left. One I thought was quite interesting. There's a few people that are actually PhDs that have very specific questions, and we may have to try and figure out a way to address those offline. But one that I think is probably pretty general that maybe you guys can touch on is, what are suggestions or recommendations you have for residents who are interested in physician sciences career, but who were perhaps not able to match into programs or institutions whose primary mission or focus is in training physician scientists?
Yeah. Well, I'll take that. I mean, I think it is, and before I, cut out the last time, I think what I was trying to say is that neurosurgery is a small community. And I think if you know what field you want to do research in, I think, reach out to, to the people, in that area, getting involved, for instance, in the sections, if you're interested in spine, getting involved in the spine section or the tumor section or the pain section, and getting to know kind of the leadership there would be helpful. And I think a lot of mentorship actually can happen outside of your institution, and so I think it's still very doable. And if you're in a residency program, I mean, your main goal is to train to be a good neurosurgeon. So I would say, you still can do that. And then, during your research year or the time that you have, outside of training, then I think you should reach out. And oftentimes, if you're not in a program that is kind of has research embedded into it, then oftentimes that does require, doing, an additional year of fellowship or something in addition that does include that.
Yeah, I would agree, especially with that last part. I mean, as hard as it may be to admit, my residency at Mass General, although I did 2 years of lab research, I had no exposure to clinical trials at all. And if I had been successful in staying at Mass General, which was what I wanted, I would probably never have done any of the things that I've done in clinical trials. So that is 100% to the credit of the people who trained me at UCSF and the people who were generous with their data at Pittsburgh and shared it with me. So I like to say to the trainees, the residents, that life is like a spectrum where at first it's your potential that matters. And when you're at my age, nobody wants to hear about your potential anymore. It's just like, what's your achievement? And at the end of residency on the clinical trials spectrum, you're still sort of in the potential field. In the bench science area, you're now early 30s with no bench science experience. That's getting to be a problem. So I think doing a fellowship that includes a solid foundation in whatever you think you're interested in is almost a necessity at that point, as well as being fun and educational almost always.
All right, I think that's a really great advice. I think one thing that I've caught from listening to this talk, maybe I'll just summarize in my own little mind, is that you have to just show a lot of interest in something and focus in on that. And I think if you have the dedication, the interest in clinical trials or in a particular research question in basic science, there's probably pathways to maneuver to engage in that pathway. If you really have in your mind what you want to do and can seek the mentorship and the resources for it. And maybe that can happen at different stages, but you just have to really want to do that and focus on it. I really want to thank everyone. I'm sorry for everyone whose questions we didn't get to. There's a lot of good questions. Maybe I'll screenshot them and try and figure out a way to respond to some of these as best I can. But I really appreciate everyone for attending and for our amazing guests and panel. I'm going to do our little outro just so the people who are attending know of some of the resources that we have available. So I'm going to do my little share screen here again. Just a reminder, next 2 weeks from now, at this time on Wednesday rather than our usual Thursday, we have another webinar session about securing jobs once you graduate from residency. So whether you're about to start residency or you're already in residency, this could be very informative for you as you go into that phase of your training. We also have a podcast, The Neurosurgeon's Journey, which we do in concert with the Medical Student Neurosurgery Training Center, who has a lot of particularly medical student-centric issues that we discuss that are go hand in hand with some of the things we cover on the webinar. If you just match this cycle, check your email. There should be an email from the SNS wanting to get your experience on a survey. This is very important as the SNS continues to design the future of the MATCH program. Also, if you're a young neurosurgeon, please take the AANS Young Neurosurgeons survey through Young Neurosurgeons NREF and the Education Committee of the AANS. They want your feedback so that they can properly design future events for you. Also, we've started a NREF fund with the purpose to both give money to mentorship for medical students through the Young Neurosurgeons Mentorship Program, as well as to honor our longtime AANS staff who was with our committee and several others who was amazing, named Chris Phillips. And we just always want to acknowledge her and her great contribution to our committee. And finally, we have a YouTube playlist on the NREF YouTube page for these webinar series. It takes about a week for them to be edited and posted, but they'll be posted there. I know there's a lot of dense information that a lot of people probably want to go back to. And again, follow us on social media for updates along those lines. And of course, you can always email us for feedback. And with that, we will exit. And we really, really want to thank Dr. Liau, Dr. Barker, Dr. Bentley, Dr. Toom, as well as Dr. Majmoonjar for their outstanding presentations and questions and input. Thank you for everyone who attended. And I will do my best to figure out a way to get your questions answered. I'm so sorry that we didn't get to all of those, but I just want to thank our awesome guests and panel. And thank you again to Becky and Anna for all their hard work putting this together. And thank you so much, everyone. And we'll catch you in a couple of weeks. Awesome.
Thank you. Bye.
Bye.